All right, so there's a little vocab that I want you to have. As far as disjointed set goes, so for example, say you have set A over here and set B over here. It's kind of like divorce, like they're apart, no overlap, nothing in common. Those would be disjointed sets. Subsets we've talked about, but say here I have B, set B, and then A is inside of B. And so A is a subset of B. Okay, and it might be a proper subset where they're not equal to each other, which in case you ditch this line down here. Otherwise, you know, we just usually do a subset. Now, the universal set is usually some big set that things are part of. So in these problems, the big rectangle represents the universal set, some big universal set, and then A and B are part of that. So the universal set might be like real numbers or something like that. All right, so if two sets are equal, if I drew them, like if this is set A, then set B would be right there. So basically, if they're equal, they have exactly the same elements. Now, what we're really going to focus on are these three. Intersection sounds kind of like they would intersect. So say here's A and B. And you're looking at the actual intersection, which is right here. Okay, and the symbol for that would be A, intersect B. And this I always think of kind of like the St. Louis Arch. It goes over the Missouri River. So it's the overlap. Like, where do these things overlap? The other thing, if you look at this thing, it kind of looks like an and. So if you write your A's kind of curvy. So that's an and situation. So it has to be in A and in B, and then we would put it there in the Venn diagram. Well, I didn't draw enough rectangles. Sorry about that. All right, let's go over here. Union then would be A and B. So we have kind of that same picture. And again, this would look like this situation. So U kind of looks like union. And in this case, think of like the word union, like marriage. When you get married, you have her stuff and his stuff and their stuff. You know, like my husband has a toaster, I have a toaster. Now we have a bunch of toasters. So union looks like this. It's kind of like her junk, his junk, the junk they overlap on, all the junk. So union, it's easy to get a lot of junk, right? Because when you're married, it's easy to get a lot of junk. Overlap or intersection, it's hard to get junk. So this is hard to get stuff. Here it's really easy to get stuff. And this is an or situation. And or is always easier than and. So for example, say I want to hire someone that has a PhD and they're willing to work for $40,000 a year. That might be tough to find. But if I just want someone with a PhD or they're willing to work with $40,000, I could probably find, because I could probably find a bunch of PhDs out there. And I could probably find a bunch of people that are okay working for $40,000 a year. It's the and that makes it hard. Okay. And then complement. Let me just draw my little thing. I guess we'll move this guy over here. So complement is basically, we write that as A prime, and that means not A. So if this is set A, the complement is everything that is not in A. So the complement means not A. Okay. So for an example, if set A is let me think. Say A is adults, then not A would be children. Okay. Things like that. And we can look at an example. So here's an example. Universal set is kind of our big set, would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then A is this right here, and B is this. So these are subsets of the universal. Now, I want to find A union B. So remember, union is or, and it's easy to get a bunch of junk. Okay, and if you think about the picture, if I had figured out how these things are divvied up, union would be all this junk, okay? So it would be everything in A and B combined. So I would write 1, 2, 3, 4, and 6, okay? So it's either one of these or one of these, okay? So you get a lot of junk when you do that. Intersection, okay, looks like overlap. Okay, it is and it is hard to get answers to this because you have to meet both requirements. Oops, sorry about that. All right, so you have to meet both requirements. So again, if you think of your picture, right, it would just be where they overlap. Okay, so if you look at the sets, where do they overlap? Well, they both have a 2 and they both have a 4. So if I were to draw a Venn diagram, 2 and 4 would be in there. So my answer to that one is going to be, just element 2 and 4 is in the and situation. All right, now let's look at the complement of A. All right, so here's our universal set up here. There's our universal set, and they're not quite all listed there, but I want it to not be A. Okay, well, what is A? A is 1, 2, 3, 4. I don't want it to be 1, 2, 3, 4. I want it to be not 1, 2, 3, 4. So if I think of that, that would be what? 5, 6, 7, 8, 9, and 10. Those would all be not A compared to, again, the universal set. All right, and then not B. All right, so if universal set is, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, compared to the universal set, I want not B. So let's see, what is B? Where do I define B? Up here, 2, 4, 6. So I don't want 2, I don't want 4, and I don't want 6. So not B, which is a complement, would be 1, 3, 5, and then what? 7, 8, 9, and 10. And that would be what the complement is called.